Hello everyone, myself Hans. Today we are going to solve the problem of UPSC 2031 Maths optional question. Here in the given question, obtain partial differential equation by eliminating arbitrary function f from the equation f of x plus y plus z, comma x square plus y square plus z square is equal to 0. This question is from topic partial differential equation. UPSC asked in 10 marks in 2021. Let's solve the problem. Given of x plus y plus z, comma x square plus y square plus z square is equal to 0. This is the form of f u comma v is equal to 0. From here, u is equal to x plus y plus z and v is equal to x square plus y square plus z square. The partial differential equation, is obtained of the form that is p plus q is equal to r. We have to find the value of p, q and r, and the p is given by, that is del of u comma v upon del of yz, and q is given by del of u comma v upon del of zx, and r is given by del of u comma v upon del of x of y. We have to find the value, that is we have to find first del u upon del x, that is del u upon del x is 1 and del u upon del y is also 1 and del u upon del z is also 1. We have to find del v upon del x, that is 2x, and del v upon del y, that is 2y, and del v upon del z is equal to 2z. We have to find the value of del u upon del x, del u upon del y, del u upon del z, and del v upon del x, del v upon del y, and del v upon del z. We have to find the value of p, q, r, and p is given. P is equal to determinant of del u upon del y and del u upon del z upon del v upon del y and del v upon del z. Put the value. P is equal to del u upon del y is 1 and del u upon del z is also 1 and del v upon del y, that is 2y, and del v upon del z is 2z. We have to solve the given determinant, that is 2z minus of 2y. This is the value of p. We have to find the value of q. We have to find the value of q. Q is given by del u upon, once again, q is given by del of u comma v upon del of zx, that is del u upon del z and del u upon del x and del v upon del z and del v upon del x. We have to value, that is del u upon del z is 1 and del u upon del x is also 1 and del v upon del z, that is 2z, and del v upon del x is 2x. We have to solve, that is q is equal to, on cross multiplication, that is 2x minus 2z. From here we can also common 2, that is x minus z, and also from here the value of p is equal to, taken to common, that is z minus y. We have to find the value of r. We have to find the value of r, that is r is given by del u upon del x and del u upon del y and del v upon del x and del v upon del y. Put the value in the determinant, that is del u upon del x is 1 and del u upon del y is also 1. Del v upon del x, del v upon del x is 2x and del v upon del y is 2y. On solving, that is r is equal to 2y minus 2x, taking 2 common, that is y minus x. Putting the value of p q r in the let this equation 1, the partial differential obtained of the form. Putting the value here, that is if p value of p is 2 z minus y into a small p plus q is plus of 2 x minus z into q is equal to r value of r is 2 y minus x. 2y minus x. On further solving, that is multiplying both the side with minus, that is minus of 2 z minus y, sorry, once again, taking 2 common first, 2 is taking common, that is z minus y into p plus x minus z into q is equal to 2 y minus x. From here 2 to 2 is cancelled, that is z minus y into p plus x minus z into q is equal to y minus x. This is the required solution of the given partial differential equation. We have to also further proceed on multiplying minus with both the side, that is on multiplying minus with both the sides, that is on multiplying with minus z and plus of y, that is y minus z into p plus on multiplying with minus, that is minus of x plus of z, that is z minus x into q is equal to, on multiplying with right hand side, minus of y and plus of x, that is x minus y. We can also proceed further. This is the required solution of the given partial differential equation. Thank you, class. we have to solve one more problem. We have to solve one more problem, that is 5 to x square plus y square plus z square comma z square minus, I think, 2xy. Z square minus 2xy. We have to solve another problem. Let's solve the problem. Given phi of x square plus y square plus z square comma z square minus 2xy is equal to 0. This is the form of phi u comma v is equal to 0. From here, u is equal to x square plus y square plus z square and v is equal to z square minus 2xy. The partial differential equation obtained, the partial differential equation obtained is of the form pp plus q is equal to r. Let this equation 1. We have to find the value of p, q and r and we have to put in equation 1. We get the required solution. First, we know that p is equal to del of u comma v upon del of yz and q is equal to del of u comma v upon del of zx and r is equal to del of u comma v upon del of xy. We have to know this basic formula and put into determinant like that. It is p is equal to determinant of del u upon del x, del u upon del y and del u upon del z and del v upon del y and del v upon del z. Del v upon del z. We have to find the value of del u upon del y, del u upon del z from u is equal to this and v is equal to this. We have to know the given formula and q is equal to del u upon del z and del u upon del x and del v upon del z and del v upon del x. We have to know the following formula and r is equal to del u upon del x and del u upon del y and del v upon del x and del v upon del y. First we have to find the value of in the determinant and then put the value. Further we have to solve, that is find from u is equal to x square plus y square plus z square and v is equal to z square minus 2xy. We have to find first del u upon del x. Del u upon del x is 2x and del u upon del y. Del u upon del y is also 2y and del u upon del z. Del u upon del z is also 2z. And we have to find del v upon del x. That is del v upon del x is minus of 2y and del v upon del y. Del v upon del y is also minus of 2x and del v upon del z is 2z. We have to put the following value in the given determinant and find the value of p. First we have to put the value in p, that is del u upon del y. Del u upon del y is 2y and del u upon del z, that is 2z, and del v upon del y. Del v upon del y is minus of 2x and del v upon del z is 2z. On solving, once again, put the value in the for q determinant, that is del u upon del z, that is del u upon del z is 2z and del u upon del x is 2x and del v upon del z. Del v upon del z is 2z and del v upon del x is minus of 2y. We have to also put the same here for r determinant, that is del u upon del x, that is 2x and del u upon del y is 2y and del v upon del x is minus of 2y and del v upon del y is minus of 2x. We have to solve for r, that is on cross multiplication, that is minus of 4x square and here minus is already present, then minus is plus, that is plus of 4y square. From here taking 4 common, that is y square minus x square. This is the value of r and we have to solve for p. Solve for p determinant on cross multiplication, that is 4yz minus is already present and on multiplication cross with minus is already, that is minus is plus, that is plus of 4xz. From here taking 4z common, that is y, 4z common, that is x plus y, and solving for q, that is q is equal to on cross multiplication, that is 2 to the 4 minus of 4yz and cross multiply this side, that is 2 to the 4 minus of 4xz. From here taking minus of 4z common, that is y plus x. We can also write q is equal to minus of 4z x plus y. Putting the value of p, q and r in equation 1, putting the value of P, this is R, putting the value of R, and this is P, this is P, and this is Q. Put into the equation 1, that is the value of P is 4z, 4z x plus y into a small p plus Q, the value of Q is minus, that is plus is minus 4z x plus y into a small q is equal to the value of r is 4y square minus x square. Taking common right hand side from 4, that is 4z, taking common 4z, that is 4z is taking common, that is x plus y into small p minus of x plus y into small q is equal to 4 y square minus x square. From here 4 to 4 is cancelled out and z is taking into denominator of y square minus x square, that is x plus y into p minus of x plus y into q, x plus y into q is equal to y square minus x square upon z. This is the required solution of the given problem. Thank you class. Again thank you for watching. We can also further proceed taking z, again get cross multiplication, that is z x plus y into p minus of x plus y into q is equal to y square minus x square is written as y minus x and y plus x. We take common x plus y from right hand side and left hand side, that is z x plus y, that is small p minus of q is equal to y minus x, and we can also write y plus x, that is x plus y. X plus y to x plus y is cancelled out and the remaining is multiply z with the following, that is p z minus qz is equal to y minus x. This is the required solution. We have to solve one more problem. We have to solve one more problem, that is z is equal to f of x plus iy plus g of x minus iy. We have to eliminate arbitrary function f and g of the given function. Let's solve the problem. Given z is equal to f of x plus iy plus g of x minus iy. Let this equation 1. Differentiating equation 1. Differentiating equation 1 with respect to x and y, we get first del z upon del x, that is f dash x plus iy, on partially differentiate x plus iy with respect to x, that is 1, plus of g dash x minus iy, and again differentiating x minus iy with respect to x, that is 1. This is equation second. And equation 1, differentiate partially with respect to y, that is del z upon del y is equal to f dash x plus iy, and x plus iy differentiating partially with respect to y, that is I plus g dash x minus iy, and x minus iy is differentiating partially with respect to y, that is minus of I. This is equation third. Equation second again differentiating with respect to x, that is del 2 z on del x square is equal to f double dash x plus iy, and x plus iy differentiating with respect to x, that is 1, plus g double dash x minus iy, and again differentiating x minus iy with respect to x, that is 1. This is equation fourth. And equation third differentiating with respect to y, that is del 2z upon del y square, that is f double dash x plus iy, and into I is already present, and again differentiating x plus iy with respect to y, that is I into I plus of, already minus is present, that is minus of g double dash x minus iy, and I minus I is already present, and again differentiating iy with respect to y, that is I into minus of I. On solving further, that is f double dash x plus iy, I into I is I square, and here also minus and minus is plus, g double dash x minus iy, and I into I is also I square. This is equation fifth. Once again taking I square common, that is f double dash x plus iy plus g double dash x minus iy. This is equation fifth. Del 2z upon del x square. From equation From equation 4 and 5, we have to eliminate arbitrary function, that is f double dash x plus iy plus g double dash x minus iy is equal to del 2z upon del x square. Putting in the equation 5, that is del 2z upon del 2, this is del y square, sorry, del 2z upon del y square is equal to I square, and I square f double dash x plus iy plus g double dash x minus iy. In place of, we have to write del 2z upon del x square from equation 4th, that is del 2z upon del x square. From here, that is del 2z upon del y square is written as t is equal to, and I, the value of I square is minus 1 into del 2z upon del x square is written as r. We have to also write, that is taking minus r into right hand side, that is r plus t is equal to 0. This is the required partial differential equation of the given problem. Everyone should like the session. We have to solve one more problem. We have to solve one more problem, that is find partial differential equation by eliminating arbitrary constant We have to solve another problem. Given phi of x square plus y square plus z square comma lx plus my plus nz is equal to 0. This is important question. We have to further phi u comma v form from here, that is u is equal to x square plus y square plus z square and v is equal to lx plus my plus nz. We have to find the partial differential equation. We have to find partial differential equation of the form, that is p small p q small q is equal to r. Let this is equation 1. We have to find the p, that is del of u comma v upon del of yz, and q is equal to del of u comma v upon del of zx, and r is equal to del of u comma v upon del of x comma y. We have to know the following formula. We have to know the following formula, and we know that p is equal to del u upon del y and del u upon del z and del v upon del y and del v upon del z, and q is equal to del u upon del z and del u upon del x and del v upon del z and del v upon del x. For r is equal to del u upon del x and del u upon del y and del v upon del x and del v upon del y. We have to know the following formula. We have to further proceed. Find del u upon, from here we have to find del u upon del x. Del u upon del x is 2x and del u upon del y, del u upon del y is also 2y and del u upon del z, del u upon del z is also 2z, and we have to find also del v upon del x. Del v upon del x is L, small l, and del v upon del y is small m, and del v upon del z is n. Putting the value of del u upon del x, del u upon del y, and del u upon del z, and also del v upon del x, del v upon del y, and del v upon del z in the following determinant, we have to find the value, that is p is equal to del u upon del y is 2y, and del u upon del z is 2z, and del v upon del y is m, and del v upon del z is n. Putting the for q, that is del u upon del z, del u upon del z is 2z, and del u upon del x is 2x, and del v upon del z is n, and del v upon del x is L. Putting for r, that is del u upon del x is 2x, and del u upon del y is 2y, and del v upon del x is L, and del v upon del y is M. We have to solve the following determinant, that is for P on cross multiplication, that is 2ny minus of 2